Welcome to the series of lectures on understanding atomic structure and periodic table. Understanding the structure of an atom and arranging them in an order is a very important aspect in chemistry. Why? Because the structure of an atom, the structure of an element, the components that an atom is made up of, and their arrangement is something that defines various properties of an element and hence the compound too. The study of atomic structure and periodic table hence is very important part of our chemistry. In this series, we will be learning about various aspects of atomic structure, discuss about isotopes, and we also discuss about how the electrons are arranged in an atom, how to represent it, which we call as electron configuration, and we also discuss about the arrangement of all the elements in an order which is called as the periodic table. Chemists are always interested to study about the world around them. And what do we see around us? It is the matter. Matter is very important aspect in a chemist's life. So what exactly is matter? Matter can be defined as anything and everything that occupies space and volume. So the book you are reading, the pen you are holding is all part of matter. Are you matter? Of course, yes, because you have volume and you're occupying space. And am I matter? Of course. And you matter to me because you also study chemistry. Chemists try to classify this matter initially, and they found that we can classify the matter as three categories: the solids, liquids, and the gases. They had realized by that time that matter has got some small particles inside them, and if the particles are very closely packed, we call them as solids. If they are somewhat loosely packed, we call them as liquids, and if they are very loosely packed, we call them as gases. In fact, Greeks classified matter as composed of air, water, earth, as well as fire. However, you can see certain things which actually does not belong to the matter. Can you think of any such things? Okay, let's continue. We realized that matter is composed of very small particles. Now, if they are composed of smaller particles, obviously the smallest particle should be something which is indivisible. It is the smallest and hence I cannot divide it. That led to the idea of an atom. Atom is a word that is derived from the word atomius. And atomius means small and the indivisible particle. You see that this concept of an atom was proposed by various people across the globe, like Kannada from India and many more. However, it was refined by a person by name John Dalton in the year 1803. He said that if I take matter and I zoom it, then I can see that they are all made up of very small particles here. Now these small particles are coming close to each other and giving rise to what I call as matter. Once it becomes macroscopic or something that I can see, I can classify them as solid, liquid, or the gas, or as Greeks proposed, I can even say whether it is made up of more of air or water or earth and fire and so on. Once chemists realized about what an atom was, the next idea was to see what exactly this atom is made up of. But John Dalton said that it cannot be broken down. Hence, there were a lot of experiments that were carried by various scientists to find out what these particles are made up of. and that led to the discovery of subatomic particles. Subatomic particles were discovered by three great scientists, of which J.J. Thomson stands first. J.J. Thomson is a renowned chemist who, in the year 1897, discovered electrons. In 1897, he proposed a model for the structure of how this atom would look like, and he said that the positively charged sphere encloses small negatively charged particles, which he called as electrons. More the positive charge, bigger would be the sphere. He called this model for an atom as the plum pudding model. This model gave an insight that there is a positive charge and a negative charge in an atom, making the atom neutral. However, the whole idea of this structure of an atom was changed by another scientist by name Rutherford. Rutherford, in the year 1917, Rutherford proposed that the atom has a very small region in the center, which he called as nucleus, and this nucleus was the site for the positive charge. And where are electrons? He said that the electrons are revolving round the nucleus. This was the model that was proposed by Rutherford, which even today acts as the basic skeleton for us to know about the structure of an atom. He performed an experiment where alpha rays were bombarded, and the way the alpha rays scattered was studied, and he came to the conclusion that nucleus was in the center, having a positive charge and electrons revolving around it. Further experiments by another scientist by name Chadwick in the year 1932 proposed the presence of another particle inside the nucleus, which he called as neutrons. He said that there is one more neutral particle called as the neutrons that is present in the nucleus of an atom, and the electrons are revolving around the nucleus. The best part about the three scientists who discovered the subatomic particles is that Rutherford was the student of J.J. Thomson and Chadwick was the student of Rutherford. Now that is how the students worked with the ideas of their teachers and saw to it that science progresses. Once we had a fair idea of how the structure of an atom is, we try to define an atom. How do I define an atom? Atom can be made up of different types. Do you agree? For example, I have copper metal having copper atoms. I have aluminium metal having aluminium atoms. I have sulfur powder, and the sulfur powder is made up of sulfur atoms, and so on. What's the difference between copper atoms and say sulfur atoms and say aluminium atoms? So I have 118 elements like that, and each 118 elements differ from each other. And if I have to define each one of them, how am I going to define? Now for that, we use certain terms, which is atomic number, mass number, and isotopes. Let us see what they are. Let's take the example of carbon. Every time, instead of writing carbon as C-A-R-B-O-N, in chemistry we always write it by one single letter, which is C, and C meaning carbon. This is what we call as the chemical symbol. Adjacent to this chemical symbol, we write certain numbers. The first number, which is written on the top here, is 6, and this 6 actually represents the number of protons present in that particular atom. In case of carbon, it is 6, telling us that there are 6 number of protons present in the carbon atom. Now we know that an atom is electrically neutral because it has 6 protons. There will also be 6 number of electrons. Please remember that I have the ability to take out an electron from carbon atom, in which case it will not be electrically neutral. It will be positively charged. Similarly, I can also put an electron into the carbon atom, in which case it becomes negatively charged, right? So in an electrically neutral atom, we say that the number of protons is equal to the number of electrons, and that is what we call as atomic number. Atomic number is very important because that is what is going to tell us which element we are referring to. Suppose there are 6 protons, I call it as carbon. There are 7 protons, I call it as nitrogen. There are 8 protons, I call it oxygen, and so on. Let's talk about another important number by which we can define how and which atom we are talking about. And that is something that we call as the mass number. Mass number in this particular case of carbon, you see that it is 12. 12 is nothing but the mass of the atom, which is also called as atomic weight. It's also called as the mass number. Now this is always the sum of number of protons and number of neutrons. Number of protons and neutrons, both of them are present inside the nucleus itself. They are not present outside the nucleus. Hence, when I say the mass number or the atomic weight, I am referring to the mass of the nucleus only. What about electron? Electron is not considered to tell the atomic weight because the mass of an electron is negligible. It is so less that if I take one proton, divide that into 1800 pieces, and one piece would correspond to the mass of an electron, which is very small and hence is negligible when I am calculating atomic weight. So knowing atomic number and mass number of an atom is something that is very important for us to know about what atom is present in the matter we are considering. Let's talk about the last aspect for this video session, and that is about isotopes. Now we know very well that our nucleus has protons and neutrons, right? The number of protons for an element is fixed. Do you agree? Suppose I have one proton, I call it as hydrogen. I have 4, then I call it as beryllium, and so on. So the number of protons is fixed. What about neutrons? Do you see that the number of protons is also equal to number of neutrons? Not necessarily. Many times we see that the neutrons might not be there at all, as we see in hydrogen. Slight addition of neutrons in a nucleus would not affect the properties of the atom, but it changes its mass number only. If we consider hydrogen, we know that it has no neutron. Deuterium, which is also hydrogen, has 1 neutron along with 1 proton in the nucleus, and tritium has 2 neutrons and 1 proton in its nucleus. And so what happens to the masses? Protium has 1 mass number, deuterium has 2 mass number, and tritium has 3 mass numbers. So you see that though all these 3 are hydrogen atoms only, their mass numbers are different, and such atoms are what we call as isotopes. So basically, isotopes are those elements whose atomic number is the same, but their mass numbers are different. You see this kind of isotopes for most of the elements, lower elements especially, like hydrogen, then you have it for nitrogen, oxygen, chlorine, and many more. The study of isotopes are very important because they are widely used in medical research, and they're also used in carbon dating and many other areas. We will know more about them in our future videos. So I hope you have got a fair idea of what an atom is and how do I give an address to an atom by its atomic number and mass number. In our next video session, let's talk about the arrangement of electrons in an atom. See you.